Okay, question 6. We've got a metal cube, otherwise known as a Lesley cube, and it's filled with hot water. So this is going to be radiating infrared. The four sides of the cube have different surfaces, and we can see that. We've got two black ones, one of which is shiny, one is matte, and two white ones, a shiny white and a matte one. The four surfaces are at the same temperature because we've got the same hot water inside the cube. They're now going to detect it using their thermal energy detector, and what we should see is the white surface emits less than the black. Black are good absorbers and good emitters. White are poor emitters. So it then says, suggest a possible millivolt reader for the shiny black surface. Well, the black one's got to be better than the shiny white one. And then we can see a matte surface is better than a shiny surface. So what we've got to do is just make sure that the value is in between those two values. So anything between 21 to 54. I hope that makes sense. So it's using the table to see matte is better than shiny, and the next one is and black is better than white at emitting. State what must be kept the same to make the measurement for each surface. We want that detector the same distance away every time, otherwise it would be a bit rubbish. There's no marks for saying the same water because it tells you that they're at the same temperature there. Suggest why the cube is placed on a block of wood. Well, clearly we know that wood is a good insulator. So that's to stop thermal energy being lost from the cube into the ground. We want it coming from the sides. All right. Well, you could have had the same exposure time, sorry. So wood is an insulator which prevents thermal energy transferring from the cube into the floor or dissipating into the ground. Next one, common question. So we've got a graph and it says a hot surface emits. We've got the intensity, so how much light, or if we were to imagine a wave, the amplitude, and then we've got the wavelength, distance from peak to peak. Remember, don't do it my way, that's pants. If you've got a wave, mark, and draw it in neatly. The number of students that just do what I do and do that and they lose a mark. Right, so now we just got to explain it. Well, it's pretty obvious. It's going to increase up to a peak, and what we're going to do is say where that peak is, so 1.1, then it decreases. So as wavelength increases, intensity increases to a peak, and then at higher wavelengths, as wavelength increases, intensity decreases. So here's it in sentences. So as wavelength increases, intensity increases to a peak of 1.1 microwatts per meter squared. And you can see I've just put that in. Or I could use the wavelength of 8 micrometers. And then with longer wavelengths, the intensity decreases. So we've got to talk about the fact that there's a peak, the fact that there's a first relationship, as one goes up, the other goes up, and then at the other, as the one goes up, the other goes down. And remember, we don't use the words goes up and down, we use the words increase and decrease. Okay, next one, 4 marks. Figure 12 shows 2 cans and a radiant heater and some apparatus. One has a matte black surface, so that's here, matte black. One has a shiny silver surface, and what we should see is this one should heat up better because it can absorb more radiant heat than the shiny one. We've got a stop clock, and that's so we can have the same time. And the basic idea, make sure they're the same distance, so we're going to need a ruler. Place them away from the radiant heater, make sure we've got the same volume of water inside each. Heat it for the same time, measure the temperature at the start, measure the temperature at the end, and this one should have increased more. So to turn that into sentences, measure the same volume of water into each can. Use the thermometer, measure the temperature of the water at the start. Turn on a heater for the same time using the stop clock, and I've picked 5 minutes. They even add in there keeping the same distance away from the can. Measure the final temperature. The one with the highest temperature is the better absorber, and in this case it should be the matte black one. So yeah, the only thing I've missed out in that answer there is I think I should have mentioned that we need to keep the radiant heater the same distance away. There's enough there for 4 marks.